Hello, boys. Very good morning to all of you, and welcome to all of you on our online class. And as usual, I'm your teacher, Jana Akhtar. Here is with your physics class. I'm going to have discussion on physics. And in my last orientation class, I have told you that we have 4 chapters for the first term exam in class 10. And the first chapter is current electricity, and today I'm going to have some discussion on the starting content of this chapter. And the very first topic of this chapter is electric current. Before that, I want to discuss some points about the difference of static current, static electricity and current electricity. As I've told earlier to you in my previous lecture that two forms of electricity, there are 2 forms of electricity. One is static electricity and another one is current electricity. And you have already known about the static electricity. You have learned the definition of static electricity. That means of whenever a chargeless, for example, is if it is an it is a chargeless object and it is just brought to a charged particle, then if they are rubbed together, on that case some charges from the charged particle just moves to the chargeless one, and thus the charge neutral particle gets some charge. And if we just remove the charged particle from here, the charge that the charge neutral object that is getting some charges from the other object, and this charge can't move freely, or they just remain as static. That's why this kind of electricity is called static electricity. But if we just maintain a situation just like that, 2 charged particles are brought together but with different potential. For example, this one is having with higher potential, and another one is of lower potential. Then the movement of charges from higher potential, and if we connect then both of them with a wire, then some charges will move from higher potential to the lower potential. That means a movement of charges is involved here, and that's why this is called current electricity, or simply electricity. So I think you have understood the difference between static electricity and current electricity. In a word, the electricity due to static charges is called static electricity, and the electricity that is involved with moving charges, that is called current electricity or simply electricity. Okay, here we will be able to know the definition of current, some definition of electromotive force, potential difference, etc. Then our topic is electromotive force, or simply EMF, electromotive force, or in short it is called EMF. The definition of EMF is an important definition. Most of the time in exams, this definition comes in exam. What is electromotive force? We have learned that for getting current electricity, the most prominent thing is maintaining potential difference between 2 objects. If there is potential difference between 2 objects, then the charges from higher potential will move to lower potential, and that is called the flow of electricity. But if for example, if we just assume a diagram like this one, that potential is charges are moving from higher potential to lower potential, and then so within some period of time, the charge of both object will be equal because the charges are moving from one to another. Then if the potential gets equal in both object, there will be no flow of charges and there will be no current, because the flow of charges is flow of electricity or current. So if there is no potential difference between two different objects, there will be no movement of charges and there will be no current as well. So for maintaining a continuous electric flow or flow of electricity, we have to ensure the difference of potential between two objects, and for doing that some extra energy or external energy has to be supplied that will maintain that potential difference, and that is done with some battery source or generator. What is the function of battery source or generator? Battery source or generator just do the thing over here that they maintain a continuous potential difference between two objects, so that the charges of flow remain continuous, and so that the current flow flows in a continuous way. For example, if you just know about the configuration of a battery, that means a battery is a combination of some chemical element, and two electrodes are used over here, positive end and a negative end. If I just want to symbolize is on a circuit, the battery symbol is just like this one. This is battery symbol. Here is positive end and here is negative end. But as a chemical component, a battery cell, or in case of structural formation, a battery has two electrode, one containing positive end and another one is negative. Positive end is called anode and negative end is called cathode. Anode means this has positive charges, and cathode means this has negative charges. So whenever these two ends are connected together, what happens over here? Here some liquid component or chemical component are just used over here, and in those components these two electrodes are just immersed, and due to this chemical component, the battery just maintain a continuous potential difference. So as we know that the positive end has higher potential, this end has higher potential, and the negative end has lower potential. And according to the if we want to say about the direction of flow of charges, always charges flows from higher potential to lower potential, and the flow of charges is called flow of current. If we want to define about the conventional current, what is current? Current means the flow of charges per unit time. We will know about the definition and unit of current in the rest part of this class, next part of this class. So now what I'm trying to say here, potential difference is maintained for a continuous flow of current, but how it is maintained? Actually, the anode end or the positive end of a battery has higher potential and negative end of a battery has lower potential, and the charges moves from positive charges moves from higher potential to lower potential, and that is called the flow of current. But flow of electron is opposite over here. Electron flows from negative end to the positive end of the charges. That means from here from negative end, the electrons are moving to this positive end, and the positive charges are just leaving this end and just moving to the another portion. And due to the chemical component used over here, the continuous potential difference is maintained over here, and that ensures continuous electron flow. But you know that every battery has a battery life. That means after using, battery gets damaged. Whenever it gets damaged, that means the chemical component just loses their ability to work. On that case, the potential of the two end, or that means anode or cathode, they are just become equal, and on that case the battery can't provide any potential difference, and that means it will have no ability to make a continuous flow of current. So I think you have understood the concept of potential difference over here, or why is potential difference is necessary in maintaining continuous electric flow. I was just talking about electromotive force. Now if we want to define electromotive force, what is electromotive force? Just look at this circuit here. Actually, for your better understanding, sometimes I will try to use some Bengali words also to make you understand everything. At first I want to say it in Bangla, the meaning of electromotive force, যেটাকে বাংলায় বলা হয় তড়িৎচালক বল। তো সেই তড়িৎচালক বল কি সেটা আগে বাংলায় বলি, then I will just explain it in English. যে একটা ব্যাটারি বললাম যে পজিটিভ এন্ড থাকছে এন্ড নেগেটিভ এন্ড থাকছে। সো এইখানে একটা একক ধনাত্মক আধানকে, ইউনিট পজিটিভ চার্জকে যদি এই সার্কিটের কোনো একটা এন্ড থেকে, ধরো এ একটা এন্ড, এখান থেকে যাত্রা শুরু করে পুরো সার্কিট ঘুরিয়ে কোষ সহ, সেল সহ পুরো সার্কিটটাকে ঘুরিয়ে আবার এই এ এন্ডে আমি নিয়ে আসবো, তার জন্য কাকে নিয়ে আসছি? একটা ইউনিট পজিটিভ চার্জকে আমি কোষ সহ একটা সার্কিটের একটা বিন্দু থেকে ঘুরিয়ে, পুরো সার্কিট ঘুরিয়ে কোষ সহ আবার সেই বিন্দুতে নিয়ে আসতে একটা কাজ হবে, সেই পরিমাণ কাজটাকে বলা হচ্ছে ইলেকট্রোমোটিভ ফোর্স বা তড়িৎচালক বল। এখন if I want to explain it in English, then what is electromotive force? The electromotive force is total work done in doing what? Total work done in bringing a positive unit charge, or in driving a positive unit charge from one end to the circuit, from one end or one point of the circuit to the same point, by traveling or by traversing the complete circuit along with the source or battery. Total work done in driving what? A positive unit charge, in driving a positive unit charge from one end to the battery, from one end to of the circuit, from one end of the circuit to the same point, or to the same end, by traversing the complete circuit along with the battery. I think I'm writing it in first, so I think you can understand my writing, or you just follow my verbal words. Okay, so কি বললাম যে total work done in driving a positive unit charge, যে কোনো একটা এন্ড থেকে একটা পজিটিভ ইউনিট চার্জকে পুরো সার্কিট ঘুরিয়ে আনবো আমি কোষ সহ বা সেল সহ বা ব্যাটারি সহ পুরো সার্কিটটাকে ঘুরিয়ে আবার সেই এন্ডে নিয়ে আসতে যতটুকু কাজ হচ্ছে, that is called that amount of work done is called electromotive force or EMF of an battery. And it is just denoted as simple equation form, W by Q. Q means Q equals, here we can assume positive unit charge, and W is the total work done. So according to this equation, what will be the unit of EMF? Definitely joule per coulomb, because the unit of work is joule and the charge is unit of charge is coulomb. So joule per coulomb is the unit of electromotive force, or বাংলায় যেটাকে বলা হয় তড়িৎচালক বল। ঠিক আছে, পটেনশিয়ালের ব্যাপারটা তোমরা বুঝেছো। আরেকটা ডেফিনেশন এখানে হতে পারে, what is called potential difference. You have known about potential or potential difference. Potential difference কি? সংজ্ঞাটা অনেকটা কাছাকাছি, just like to electromotive force. Potential difference, what is potential difference? If we just assume an electric field over here, you know about electric field, একটা চার্জ তার আশেপাশে যতটুকু এরিয়া জুড়ে তার প্রভাবটা বজায় থাকে, that is called electric field. সো এরকম একটা ইলেকট্রিক ফিল্ডের একটা পয়েন্টে একটা ইউনিট চার্জ আছে, ধরো সেই পয়েন্ট থেকে, ধরো এটা এ পয়েন্টে একটা চার্জ ছিল, তাকে আমি বি পয়েন্টে নিয়ে যেতে চাই। সো নিয়ে যাওয়ার জন্য একটা কাজ হবে, that is called potential difference. The amount of work done to bring a positive unit charge from one point of an electric field to another point is called potential difference. যদি এ পয়েন্ট থেকে বি পয়েন্টে একটা ইউনিট চার্জকে নিয়ে যেতে চাই, এক্ষেত্রে potential difference হবে VB minus VA. নিয়ে যাচ্ছি কিন্তু we are just bringing the unit charge from point A to point B, but here the potential difference will be VB minus VA. VB is denoting the potential of point B, because the charge has moved to the point B, it will have higher potential, and VA is the potential of point A, that is VA. Okay, so this is the this is called potential difference. You have known about the definition of electromotive force and definition of potential difference. And now if I want to explain the direction of current, or কারেন্টের ডিরেকশন, ইলেকট্রিসিটি আর কারেন্ট কি সেটা আমরা বুঝলাম, কারেন্টের ডিরেকশন কি সেটা বোঝার একটু প্রয়োজন আছে। কারেন্টের ডিরেকশন বলতে কি বোঝায়, যে একটু এই, ইফ আই জাস্ট ওয়ান্ট টু লুক অ্যাট দিস ডায়াগ্রাম, এখানে আমি কি বলেছিলাম, আমি আবার বাংলা একটু রিপিট করছি, যে একটা দুইটা অবজেক্টের মধ্যে ইলেকট্রিসিটি ফ্লো হতে হলে কি হতে হবে, একটা অবজেক্টের পটেনশিয়াল, এটা একটা অবজেক্ট এ ধরলাম, another object is for example B, that is chargeless. সো তাদের মধ্যে যদি ইলেকট্রিক ওয়্যার দিয়ে কানেক্ট করি, দেন পটেনশিয়াল ডিফারেন্সের কারণে এ থেকে বিতে কিছু পরিমাণ চার্জ মুভ হবে। এ থেকে বিতে কিছু পরিমাণ চার্জ মুভমেন্ট হলো, সেক্ষেত্রে ডিরেকশন অফ কারেন্ট, দ্যাট ইজ অ্যান ইম্পর্টেন্ট ফ্যাক্ট ওভার হিয়ার. Direction of current or direction of electron flow, if both are same over here, that is an important fact. এই টপিকটা, এই পয়েন্টটা নিয়ে আমরা নেক্সট ক্লাসে আলোচনা করব. We'll try to discuss about current, definition of current, definition of direction of electric current and direction of electron flow. তার আগে যেটা বলছিলাম, একটা পয়েন্ট লাস্টে ইনক্লুড করতে চাই, ইলেকট্রোমোটিভ ফোর্স। তো বললাম প্রত্যেকটা ব্যাটারি সেলের কিন্তু একটা পটেনশিয়াল ডিফারেন্স থাকে, এবং কনভেনশনাল যে ব্যাটারি সেলগুলো আমরা ইউজ করি সেগুলোতে পটেনশিয়াল ডিফারেন্সটা হচ্ছে 1.5 ভোল্ট মতো। যে ড্রাইসেল ব্যাটারি বা কনভেনশনাল ব্যাটারি যেগুলো আমরা ইউজ করি, সেখানে যে পটেনশিয়াল ডিফারেন্স মেনটেন করা হয়, দ্যাট ইজ অলমোস্ট 1.5 ভোল্ট। সো আমরা 1.5 ভোল্টের পজিটিভ ব্যাটারি ডিজাইন করতে পারি, নেগেটিভ ব্যাটারি ডিজাইন করতে পারি। ফর এক্সাম্পল, if I just draw a simple battery circuit over here, this is called positive 1.5 volt, because this point denotes the ground point. Ground means its potential is 0, that means total positive 1.5 will arise over here. So this is called a positive 1.5 volt battery. If we want to design at negative 1.5 volt, then what will be the design over here. This is a battery, and here if I want to connect negative 1.5 volt, then negative end will be connected here and positive end will be connected with the ground end. That means positive end is having potential 0, but negative end, this is having potential minus 1.5 volt. So this is a minus 1.5 volt battery, and this one is plus 1.5 volt battery, because negative end is connected with ground. That means negative end's potential is 0 and the positive end is connected to 1.5 volt. That means total potential of these batteries plus 1.5 volt. And thus we can design more battery, positive or is of with positive and negative potential. So আজকের ক্লাস শেষে তোমাদের জন্য কিছু কোয়েশ্চেন থাকছে, ছোট ছোট দুটো কোয়েশ্চেন থাকছে, সেটা তোমরা অ্যাজ আ ক্লাস ওয়ার্ক হিসেবে সাবমিট করবে ইন দ্য কমেন্ট সেকশন অফ দিস ক্লাস, যেটা হচ্ছে হোয়াট ইজ কল্ড ইলেকট্রোমোটিভ ফোর্স, what is called electromotive force or EMF, including its unit, and then what is potential difference, what is potential difference, and third one is what is the difference of static electricity, static and current electricity. Just write down the answer of these questions and place on the comment section of this class, and in next class we will have more discussion about some other topics. Till then, goodbye and take care, stay safe. Thanks to all.